All right, for today, we're going to move into trigonometry. Trig is a part of geometry. So, matter of fact, in college, they even do a whole semester or quarter, depending on the college, on trig. It's very, very important. So, what we're going to be starting, I know I zoomed out. I don't see the questions here because I'm going to explain things first. Let me start with a right triangle. So, for this idea, we need to have a right triangle. And I know a right triangle is basically a triangle where one of my angles is 90 degrees. So for today, we're going to start with a right triangle. Algebra 2 even extends a little bit more. What if it's not a 90-degree angle? Like they extend a little bit more, but on a right triangle, the three sides have a name. We have known the hypotenuse. The hypotenuse is something we have known. So I'm going to say that's the biggest side. So let me just write this thing down. Hypotenuse. I forgot my pen today, so I'm actually writing with my finger. So there it is. So hypotenuse, that's the biggest side. Now, the other two sides of a right triangle, they also have a name. We're going to use the words opposite and adjacent. The other two sides, one of them is going to be called opposite. The other one is going to be called adjacent. Opposite means far away. Kind of like imagine when you're walking down the street and you see the opposite side, right? That is far away. Adjacent is the fancy word for saying close to or next to. So remember, opposite means far away and adjacent means close to. Now, what I'm going to be doing, let me zoom in a little bit more. I'm going to mark an angle. So I'm going to come over it and I'm going to, let's say I give you guys an angle. I can either mark it with just an arc. Sometimes we use the Greek letter theta. So I can mark it with a letter, or sometimes we put a letter outside. I can put an like A, right? I can mark an angle. Now the other two sides, based on this angle, I'm gonna say this side right here, where I'm writing things out, this is gonna be called my opposite. Remember, opposite means far away. So that's far away from my angle. And this other side right here is gonna be adjacent. Hypotenuse is always the biggest side, but then opposite and adjacent depend on the angle that I gave you. Opposite again is far away, adjacent is close to. So those are the names that I'm going to be using for my sides. Now there's going to be three ratios, and ratio is basically the fancy word for fraction. There's going to be three ratios. One of them we're going to call sine. Well, in fact, right now, let me call it sine of theta. So the sine of the angle. Another ratio we're going to use cosine. And then the third ratio, we're going to call this tangent. Like I said, we're going to be looking at three ratios, three fractions. Now, sine, the first one, is going to be opposite over, because I'm going to do a fraction. Remember, I said ratio is a fraction. So I'm going to do opposite over hypotenuse. The ratio of cosine is going to be adjacent over hypotenuse. And then tangent, the ratio for tangent is going to be opposite over adjacent. I'm going to ask you guys on your work, give me the ratio. Now, the words sine, cosine, tangent, we're going to abbreviate those. Right? We're going to abbreviate it, especially because we use calculators. We don't want to write the whole word in just one key. So we're just going to abbreviate this to the first three letters. So it is not going to be the first one. We still call it sine, it is not going to be sin. Many people call it sin. And I always, as a joke, I tell people it is a sin to call it sin. It is sine. It is still pronounced sine. We're just going to abbreviate it using the first three letters. The second one is not going to be cos. It is still going to be pronounced cosine, but we're going to abbreviate it using only the first three letters. And obviously tangent, only the first three letters. Okay, so make sure you guys know how to do this. Okay, so now let me zoom out here. So in fact, let me give you guys an acronym. I know you guys have heard of acronyms before. You guys have heard of PEMDAS. PEMDAS for order operations. Let me give you guys an acronym for trigonometry. Our acronym we're going to use is going to be SO, CA, TOA. What that means is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. That is how I'm going to do my acronym. That's how I'm going to help. That's what's actually going to help me out. So now let's take a look at question number 45 on our notes. Find the value of each trigonometric ratio. First of all, let me label my three sides. I know the biggest side is the hypotenuse. So let me just say 29 is the hypotenuse. I notice here I'm asking tangent of angle C. So that means that angle C is the one that is marked. So based on angle C, the other sides, one of them is opposite, the other one is adjacent. 20 is the opposite and 21 is the adjacent. Remember, opposite means far away, adjacent means close to. And I remember tangent is opposite over adjacent. So I'm just going to write 20 over 21. If I can simplify my fraction, then do so. Right? 20 and 21 cannot be simplified. But again, if you can simplify the fraction, do simplify it. All right, now let's take a look at number 46. Let me label my sides first. I know the biggest side is the hypotenuse. That's where I always start. So I'm going to say the biggest side is the hypotenuse. So 37 is the hypotenuse. The other two, one of them is going to be called opposite and the other one's going to be called adjacent. And then because I see that I'm asking for tangent of angle C, that means we have angle C here. And then 35 will be the opposite and 12 will be the adjacent. Again, opposite means far away. Adjacent means close to. Now, tangent, I remembered the acronym SOHCAHTOA. So I'm going to go, I know tangent. Again, I'm going to remember the acronym. I'm going to remember TOA for SOHCAHTOA. What that means is tangent is opposite over adjacent. So I'm just going to go 35 over 12. If we can simplify for fractions, by all means do so. This one I cannot simplify, but like I said, if I could, then I would. It is okay for the big number to be on top of the fraction, right? It is okay to have improper fractions. 35 over 12, that's fine. Have a question on the chat that says, is the bigger side always the hypotenuse? Yes, always. The biggest side is always the hypotenuse. The other two sides are opposite and adjacent. Hypotenuse is just a hypotenuse, the biggest side. Opposite and adjacent depend on the angle that I'm asking, the corner that I'm asking. All right, so hopefully you guys are like, this is not too hard, and it is not. Let's take a look at number 47. First, let me label the sides. The biggest side is always the hypotenuse. So in this case, 17 is the hypotenuse. Because I have to identify my sides. The other two sides, one of them is opposite, the other one is adjacent. Opposite means far away, adjacent means close to. So then I look at the title. It says cosine of angle Z. So that means that I'm marking my angle Z. So 8 will be the opposite because it's far away from Z. And 15 will be the adjacent because it's close to. All right, so cosine, I remember the acronym, so ka toa. I'm using ka because it starts with a C of cosine. Cosine is adjacent over hypotenuse, A over H. So I'm going to go 15 over 17. And again, if I can simplify my fractions, do so. This one we cannot. So it's just 15 over 17. And then question number 48. Let's take a look at 48. Let me label my sides. The biggest side is hypotenuse. That's the biggest side. Now, the other sides, again, one of them is the opposite, one of them is the adjacent, based on tangent of angle angle C. So I'm going to look at corner C, and I'm going to say 16 is my opposite, 12 is my adjacent. Again, opposite means far away, adjacent means close to the corner C. Now, tangent, I remember the acronym TOA. I know that means tangent equals opposite over adjacent. So I'm going to go 16 over 12. And again, simplify your fraction if you can. This one we can. The number 16 and 12, let me divide each by 4. So my answer will be 4 over 3. Again, simplify your fraction if you can. So I have another question on the chat. It says, so the letter that's being asked will be the angle? Exactly. Exactly. The letter that we have after sine, cosine, or tangent, that's the angle. So let me zoom out here. Let me come back to the beginning of our lecture here. Remember, hypotenuse is always the big side, always. The other side is either opposite or adjacent, depending on the angle that I gave you. And for you guys to remember the acronym for the ratio, for the fraction, SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent equals opposite over adjacent. So hoping right now you guys are like, all right, cool. This is not going to be too hard. And it is not. Trigonometry is actually very, very useful. Now we can even use, let's imagine you guys might be wondering, when do we use geometry? Or when do we use trigonometry? Imagine I have a river and I want to measure the distance across the river. And let's say this river, I cannot get in the river. Let's say it's Kern River. I cannot get in it. However, I can measure one side outside, right? I can be standing on one side of the river. I could be looking at a rock on the other side, and then I create an angle. So I can easily get an angle. I can easily get a side. That is enough for me to be able to find the length across the river. All I need is one angle and one side. And let's take a look. How am I going to do that? Here, question number 49. It says, find the missing side. So I have triangles here. I have some triangles here, and round your answer to the nearest 10th. Let me label my sides first. And what I mean with label my sides as in hypotenuse, opposite, adjacent, let me see what information do I have. So I have the hypotenuse. I have a corner now. Now I have a 15 degrees, but that's my corner. And yes, I have a question here. Simplify. Yes, always simplify your answers. And yes, that's how you simplify. Okay, so coming back to number 49, 15 is the hypotenuse and X is the adjacent. I don't have the opposite side. Remember, opposite side is the one far away from the angle. So I'm looking at I remember my acronym, so ka toa. And I see I have the letters A and H. I have the adjacent and the hypotenuse. Based on that, I'm going to be using cosine because of ka. So I'm going to write cosine of 15 degrees is equal to X over 15. Notice I went cosine is equal to adjacent over hypotenuse. When I'm solving for a fraction, when I'm solving for a letter, I hope the letter is on top, which in this case it is. And the reason why I hope that, because the way I get the letter by itself, I multiplied by 15. I'm going to multiply both sides by 15. Because that's going to get the x by itself. So that gives me x is by itself. I'm just going to grab a calculator and I'm going to find out what's 15 times cosine of 15. All right, so in this case, let me share a calculator here. Google is a calculator. So let me share this calculator here. Make sure you guys are dealing with degrees. I see my calculator has radians and degrees. Make sure you're dealing with degrees. So I'm gonna make sure degrees highlighted. I have to deal with degrees. And I know I'm solving for 15. So I'm just gonna type it in. 15 times, I see here, cosine of 15. I even close my parentheses. So I typed in what I want and I press equal. And it gives me a number. My instruction said round it to the nearest tenth. I know nearest tenth sounds like the number 10, 1 with 1 0. So because the number has only 1 0, my answer should only have 1 decimal place. So I'm looking at my first decimal place, but I still take a look at the second decimal place, in this case 8, because my second decimal place is big enough. Big enough means 5 or more. Because this 8 is big enough, it brings the forward up. So my answer will be 14.5. So let me come back to our work here. My answer, x, will be 14.5. Again, I just typed it in. Let's take a look at question number 50. Let me label the sides that I have. I have the hypotenuse, and based on 42 degrees, I have the opposite. And I remembered, from my acronym, I remember the part so. The one that uses O and H is so. So in that case, I'm going to be using sine. Let me write this as sine of 42 is equal to, I know opposite over hypotenuse, so let me go 16 over x. It was nice when the x was on top, but in this case, it is not. So I'm going to show you guys a trick. The left side, let me make it into a fraction. I'm going to make both fractions, and then I'm just going to flip my fractions. So I have that 1 over sine of 42 is equal to x over 16. I like to have x on top because it's easy to deal with x. Now that I have the x on top, let me multiply both sides by 16. So on my fraction, let me put my 16 on top. So I have that x is equal to 16 over sine of 42. All right, let me go back to my calculator. And I know I have to type in 16. So 16 divided by sine of 42. I see that, yeah, that's what I want. 16 divided by sine of 42. It gives me 23.91. My second decimal place is too small, right? 4 or less is small, so I'm going to ignore it. My answer in this case will be 23.9. So x is equal to 23.9. If you have a scientific calculator with you, make sure you guys use it properly. If you guys are using your phone, make sure you know how to use it. Make sure come back to intervention. Remember, I have intervention. Make sure you guys come back because it has its own way of how to do things. All right, so now let's see. Let's continue. Let's take a look at number 51. I'm solving for a side. Let me label the sides that I have. I have the hypotenuse, and based on the 40 degrees, I have the adjacent. I remember my acronym. I remember the part K. Now, what that means is that cosine is adjacent over hypotenuse. So I'm going to write cosine of 40 degrees is equal to 17 over x. I have x at the bottom, so let me make two fractions. Cosine 40 over 1. Let me flip my fractions. 1 over cosine of 40 is equal to x over 17. Now I can multiply both sides by 17. I'm going to put a 17 on top of each fraction because that's going to give me x by itself. Now I'm just going to grab my calculator. I'm going to go 17 divided by cosine of 40. Let me type this in. 17 divided by cosine of 40. And it tells me 22.19. The 9 is big enough, so it's going to push the 1 over. So my answer will be 22.2. So let me come back to my work here. I'm going to say x equals 22.2. So I'm dealing with decimals, and it's fine. Question number 52. I have the hypotenuse, and I have the opposite. Right, based on 50 degrees. And no, you don't have to, on the homework, make sure you don't type in x equals, just type in the number. So looking at number 52, I remember O and H, I remember the acronym SO. So that means is that sine of 50 is equal to x over 16. Sine is opposite over hypotenuse. I have the x on the top, so that's good. I don't have to flip my fractions. I'm just going to multiply both sides by 16. Because that gets my x by itself. Now I'm just going to grab my calculator. I'm going to go 16 times sine of 50. So let me share my calculator here. 16 times sine of 50. That's what I had, right? Yeah, 16 times sine of 50. It tells me 12.25. All right, the 5 is big enough, so it's going to give me 12.3. Come back to my work. 12.3. Okay, so we said we can use this to find the measurement of the width of a river. We can also use this also for the height of a building. I know we used similar triangles before, but this one we can also use it for the height of a building where I cannot get the shadow. All right, now last thing I'm going to use is to find the measure of the angle. Now here I have an angle. It says find the measure of the indicated angle to the nearest degree. Very important. Nearest degree. What that means is that my answer will be a decimal. Expect your answer as a decimal, rounded to the nearest whole number. So even though when I'm gonna type this on my calculator, I'm gonna get a decimal. My answer, I will not have decimal. I'm gonna round it to the nearest degree, so that means the nearest whole number. All right, so let's take a look. Let me label the sides that I have. I have the hypotenuse. Based on the angle, I have the opposite. And like I mentioned before, when I don't know the value of something, in this case, a question mark, I always call it x. So I have the opposite in the hypotenuse, so I'm going to use sine. So I'm going to say sine of x is equal to 49 over 53. I can find out what's 49 divided by 53, right? It's going to be a long decimal, but I'm not going to worry about it yet. I wish I had x by itself. I wish I had x by itself because that's what I'm solving for. But I cannot just move the sign, right? I am going to move it to the other side, but instead of just the regular side, I'm going to call this sine inverse. It looks like to the -1. And as a matter of fact, let me open my parentheses, and inside I'm going to write 49 over 53. I moved sine from one side to the other side, but then I'm going to call it sine inverse. Some people even call it arc sine, but I'm going to call it sine inverse. Like I said, it looks like a sine to the -1. Let me grab my calculator. And I see here, I see sine, but I don't see sine inverse. However, here at the side, I see the key for inverse. Let me press that. And then I see sine inverse. So I'm going to type in sine inverse. So again, I go my inverse, sine inverse. Remember, I call it sine inverse and we called it arc sine. And that's fine. It's arc sine of 49 over, I use the divide for over 53. I press equal. It says 67.5. I said I was going to round it to the nearest whole number. The 5 is big enough, so my answer is going to be rounded to 68. So let me come back and I'm going to say x equals 68. And again, on your homework, you don't type in x equals, just type in 68. All right, that's not bad. Let's take a look at question number 54. I have the hypotenuse, I have the adjacent, and I'm solving for x. Now, I have two questions. Can you show how you did the arc on the calculator? Yes, I'm going to show you guys again. Remember, I'm showing my arc. Now, another question says, is that also on the phone calculator? Yes, it is, but you have to flip your phone. In order for your phone or your calculator to be scientific, you have to flip your phone, but instead of going sine and then the number, you have to type it in backwards. Come back for intervention at 11, and I'll go over how to type it in your calculator. Okay, now coming back to number 54. I have adjacent and hypotenuse. So therefore, I'm going to use cosine. I'm going to say cosine of x is equal to 8 over 14. So to get x by itself, I'm going to move cosine to the other side as a cosine inverse of 8 over 14. So now let me go to my calculator. And I'm going to see inverse here. I press my inverse, so it gives me cosine inverse. You guys see here. As soon as I press cosine inverse on my screen, it's going to say arc cosine. But I see cosine inverse. Oh, no. Okay, so inverse, I press. So see how it says arc cosine, which I know it's cosine inverse. And then inside my parentheses, I type in 8 divided by 14 and close my parentheses. 8 divided by 14 is basically 8 over 14. All right, then I press equal. And it says 55.1. All right, the 0.1 is too small, so I'm just going to ignore it. Remember, I'm rounding to the nearest whole number. So my answer here will be 55. All right, so let me come back to here. And I'm going to say x equals 55. All right, let me do a couple more examples. 55 here. Let me label my sides. I have the hypotenuse and I have the adjacent. Therefore, I'm going to use cosine. I have the cosine of x, because remember the question mark, I call it x. Cosine of x is equal to 6 over 10. That means that x is equal to cosine inverse of 6 over 10. Let me go to my calculator. You guys can see my calculator. So I need cosine inverse. So I go inverse cosine, and then I type in 6 divided by 10 equals 53.1, which is just 53. Let me come back here. I'm going to say x equals 53. And again, when you're typing this, just type in the number. Let me do one last example. I have the hypotenuse and I have the opposite. Remember, I label my sides based on my angle. Hypotenuse is always the biggest, but based on the angle, 46 is the opposite. O and H, I'm going to use sine. Sine of x is equal to 46 over 56. Remember the acronym SOHCAHTOA. That's how I know whether I use sine, cosine, or tangent. So I'm going to say x is equal to the sine inverse of 46 over 56. All right, let me go to my calculator. You guys want to use the one that I use? I just went to Google, typed in calculator, and this is what I got. Again, as a reminder, I press degree because we have to deal with degrees. Make sure degree is highlighted. Okay, so I'm looking for the sine inverse. So I press inverse sine, and then I typed in 46 divided by 56, close parentheses, and it gives me 55.2. When I round it to the nearest whole number, that's 55. So x is equal to 55. Notice that when I was dealing with degrees, when I was doing the degrees, even though my answer was a decimal, I typed it in as a whole number. So rounded to the nearest whole number. Coming back, when I was asking you to find a side, we rounded to 1 decimal place. So yeah, that one you do have a decimal. I have a comment here in the chat. This is easy, but it's the work that will be a little harsh. And then don't forget the ratio. The beginning was just a simple fraction. So let me zoom out. Let me zoom out here. Hopefully you guys take a screenshot. So take a screenshot. Those are your notes.